Welcome. In this lecture, I want to go through kind of simpler notation for integration by parts, so it'll kind of be easier to work with. This one is easier in terms of feeling more familiar, but it's a little clumsy. And so as you do it, you might wish you had something a little simpler to work with. And something I first want to emphasize here is that, in combination, this together with this, right, these together are actually right, this is the same thing as df, which is f prime of x dx. I put a reminder of that kind of notation there, with the reminder that it's not so scary. You can get used to notation. I know a lot of times we see notation. I do this, everybody does this. We see new notation, it feels overwhelming. And really the thing is just you get used to it as you work with it. So don't feel overwhelmed. You can do it. So let's do this. So with new, simpler notation, let's look at this. So with new, simpler notation, I'm going to try to write it right underneath so you can kind of see how they correspond. What do we get? We get the integral of, and then we have u dv is going to equal, and so we get uv minus the integral of v du. And you can see how that's the same thing, right? Where my u is my f of x, and my v is my g of x. Okay? So let's look at an example. If I had the integral of, and I am going to suggestively color it, e to the x dx. Okay, then this would equal, and then we have, okay, so this is my u, this is my dv. So over here we have, so we have u equals x, du equals dx. We have my dv is e to the x dx, so we have dv equals e to the x dx, right? In this one we're differentiating, and let's just keep reminding ourselves of this. In this one, what did I do? I took the derivative, and why is this dx? Because, like, let me just kind of emphasize this here. This is 1 times dx, because 1 is the derivative of x. So here I just took the derivative, right? And in this one I need to take the antiderivative. So take the antiderivative. But lucky for us, the antiderivative of e to the x is just e to the x, right? So we get here that v equals e to the x. Okay, so now we can just put that in for over here. So we want our u, so we get that from there, and that's x. We want our v, we get that from there, it's e to the x. And then we want to subtract off the integral, and then our v, so that's e to the x. And then our du, which is just dx. And then you can go ahead and keep going and integrate this. So this is going to equal x e to the x minus, and then the integral of e to the x we know is just e to the x. And we don't forget our plus c. And then you can just kind of pull out, if you'd like, x minus 1 because it's in both of these terms. Okay. And then we'll go ahead and box our work so that we know that we're done. Okay, so what did we do here? This is just, this notation is actually easier to work with. You just have to get used to it. I like to introduce the other notation first because it feels more familiar. Like you kind of understand it more rapidly. But then once you understand that one, hopefully you can shift to this one. Then this one's easier to work with. With the trick kind of being that this is like our df, where we have f prime of x and dx. And so that turns into our du, right? I swapped the order here just so that it looks nicer. And then, right, our G is our V. And then we just kind of apply it. Remember that you have to take the derivative and then put the dx, so you're kind of taking the differential. And here you're taking the antiderivative. Okay, so I hope that made some sense. And I will see you in the next lecture.